Hey, it's Miss Harris, and I'm thrilled that you're tuned in to see what's happening with Miss Harris. Multi-step equations are equations that involve multiple or many steps. These steps may include a combination of skills such as inverse operations, simplifying variable expressions, the distributive property, etc. The order of solving multi-step equations. Don't call me after midnight. This acronym will be used to give us a specific order to solve multi-step equations. It is kind of similar to the acronym we use for the order of operations, PEMDAS, or Please Excuse My Dear Aunt Sally, which is also an order that we use to solve the operations of addition, subtraction, multiplication, or division. Don't Call Me After Midnight, or DCMAM. This acronym represents all of the skills that will be used to solve multi-step equations. For example, D represents the distributive property. C represents combine like terms, one side of the equal sign at a time. M represents move the smaller variable. If variables are on both sides of the equal sign, we will use inverse operations to undo the variable with the smaller coefficient. A represents add or subtract the constant using inverse operations. And last but not least, M. M represents multiply or divide. If you're left with the coefficient, you will use inverse operations to divide. If you're left with the denominator, then you'll use inverse operations to multiply. Our first example, solve. Negative 4x minus 6x equals negative 20. We'll begin the problem by drawing the line down the equal sign to balance our equation. Then we're going to use the acronym DCMAM, or Don't Call Me After Midnight, to guide us in our problem solving. First, we'll check for the distributive property. If we look on the left side of the equal sign or the right side of the equal sign, we don't see any parentheses. Seeing parentheses denotes the distributive property. So no parentheses, we won't have to distribute. Now the letter C represents combine like terms. On the left side of the equal sign, we will check if there are any like terms. On the left side of the equal sign, we notice there are like terms, negative 4x and negative 6x. To combine like terms, we'll go ahead and combine those. Negative 4x minus 6x equals negative 10x. Then we'll look on the right side of the equal sign to see if there are any like terms. We only see the constant negative 20, No other like terms, so we're good. We'll just bring that on down. Next, we'll check for M. The first M stands for move the smaller variable. There's only one variable on the left side of the equal sign. If you notice, we're left with negative 10x equals negative 20. There's only one variable, x, which is on the left side of the equal sign. So no variables on both sides. We can scratch that out. Now we'll check for A. Add or subtract the constant. We know the whole purpose of solving an equation is to isolate the variable. On the left side of the equal sign where we see the variable x, there's not a constant. Therefore, we won't have to use A. Now we'll check for M, multiply or divide. Here we're left with negative 10x. Negative 10 is the coefficient that's being multiplied by the variable x. Yes, you heard me say multiply. Therefore, we'll use inverse operations, which is divide. We'll end up dividing both sides by negative 10. This will leave us with x equals positive 2. Negative 20 divided by negative 10 is positive 2. Our final solution is x equals 2. Now let's look at the second example. Solve. Negative 2 times the difference of p minus 8 equals 14. In order to solve this problem, we'll first draw the line down the equal sign to balance the equation. Then we'll use the acronym, Don't Call Me After Midnight, to guide us in our problem solving. So first, we'll check for the distributive property. We see on the left side of the equal sign there are parentheses. So we will distribute negative 2 times p, which is negative 2p, and negative 2 times negative 8, which is positive 16. We also see that we can't distribute on the right side of the equal sign. Therefore, we'll just bring down the equals 14. Now, let's check for C, combine like terms. On the left side of the equal sign, there are no like terms. We only see negative 2p and positive 16. They're not like terms because the negative 2 has a variable, 16 is a constant. Also, on the right side of the equal sign, all we see is the number 14, that constant. No like terms, so therefore we can cross out C. Now let's move on to M. Move the smaller variable. We only see one variable in negative 2p plus 16 equals 14. That's the letter P on the left side of the equal sign. No variables on both sides, so we can scratch out that M as well. Now we're down to A, add or subtract the constant. Well, the constant term is 16. This 16 is positive. Since it's listed as plus 16, we'll use inverse operations to subtract 16 from both sides of the equal sign. This will leave us with negative 2p equals negative 2. 14 minus 16 is negative 2. Now we'll move on to M. M stands for multiply or divide. Well, here we have negative 2p equals negative 2. On the left side of the equal sign, p is being multiplied times the coefficient negative 2. So we will use inverse operations, which the negative 2 times p, that multiplication, the inverse is division. Therefore, we will divide both sides by negative 2. This will leave us with p equals negative 2 divided by negative 2 is positive 1. Our final answer is p equals 1. Now let's look at the next example. Solve. 0.25 times the sum of x plus 4 minus 3 equals 28. We'll begin the problem by drawing the line down the equal sign to balance the equation. Then we will use our acronym, Don't Call Me After Midnight, to solve the problem. First, let's check for the distributive property. Are there parentheses in this problem? Yes, there are parentheses on the left side of the equal sign. So we will multiply 0.25 times x. 0.25 times x is 0.25x. Now we'll multiply 0.25 times positive 4. Once we multiply those, we'll end up with positive 1. Here's where the parentheses closes. That means that we're done with distributing. Everything else we'll just bring down. The minus 3 equals 28. We see here there are no more parentheses, so we're done with D. Now we'll move on to C. C stands for combined like terms. So let's check for like terms on the left side of the equal sign. We notice there are like terms. There are two constant terms on the left side of the equal sign. We have positive 1 minus 3. If we combine those, we'll be left with negative 2. Now, if we look on the right side of the equal sign, all we see is 28, just that constant, no like terms. So we'll bring down everything else. The 0.25x minus 2 equals 28. Next, we'll check for M. Move the smaller variable. Well, if you look at that equation, all we have is just that x. That x is on the left side of the equal sign. No x's are on the right side of the equal sign, so we don't have to do M. We can scratch that out. Now let's check for A. Add or subtract the constant. Well, yes, there is a constant on the left side of the equal sign with the variable. Remember, we cannot isolate the variable until the constant has been removed. That constant minus 2, we're subtracting by 2. We'll use inverse operations to add 2 to both sides of the equal sign. This will leave us with 0.25x equals 30. 28 plus 2 equals 30. Now, to isolate the variable, we'll move on to the last M. 0.25x equals 30. The 0.25x is being multiplied. Therefore, we will divide both sides. We'll use inverse operations to divide both sides of the equal sign by 0.25. This will leave us with x equals 120. 30 divided by 0.25 equals 120. Well, there goes our final answer. X equals 120. Here's our next example. Solve. 1/4 times the sum of x plus 3 equals 1/2 times the sum of x plus 2. We'll begin the problem by drawing the line down the equal sign to balance the equation. Then we'll use our acronym DCMAM, don't call me after midnight, to guide us in our problem solving. Let's check for D, the distributive property. Can we distribute? Yes. On the left side of the equal sign, there are parentheses. Therefore, we'll multiply 1/4 times x. That leaves us with 1/4 x. Then we'll multiply 1/4 times positive 3, which is positive 3/4. Now we'll multiply, on the right side of the equal sign, a new set of parentheses. We'll multiply that 1/2 times x. That'll leave us with 1/2 x. Then we'll multiply 1/2 times positive 2, and that gives us positive 1. Let's be sure to bring down anything else that we haven't touched, just the equal sign. Now let's move to the next part of the acronym, C, combine like terms. Are there any like terms on the left side of the equal sign? No, there's not. We're only left with 1/4 x plus 3/4. They're not like terms. Only one of those fractions has the variable x. On the right side of the equal sign, are there like terms? No. 1/2 x plus 1. Only the 1/2 has a variable, so no like terms there. Therefore, we can cross out the letter C. Now we'll move on to M. Move the smaller variable. Are there variables on both sides of the equal sign? Yes, there are variables on both sides of the equal sign. So what do? When there are variables on both sides of the equal sign, it's quite simple to move the smaller variable. That helps to alleviate any negatives, or as many negatives as possible. Okay, so 1/4 x is on the left side, 1/2 x is on the right side of the equal sign. 1/4 x is smaller than 1/2 x. The coefficient 1/4 is smaller than the coefficient 1/2. Therefore, we will do the opposite. We move the smaller variable by using inverse operations. The opposite of 1/4 x is -1/4 x. Therefore, we will subtract 1/4 x from both sides of the equal sign. This leaves us with 3/4 equals 1/2 x minus 1/4 x equals 1/4 x. Then we'll bring down the plus 1. Now let's move on to the next letter in our acronym, A. Add or subtract the constant term. Our variable x is on the right side of the equal sign. The constant term is plus 1. The opposite of adding 1 is to subtract 1. So now we will subtract 1 from both sides of the equal sign. This will leave us with 1/4 x equals -1/4. 3/4 minus 1 equals -1/4. Our last step, M. We know we're not done because there's still an x. Our variable is still not isolated. So we're left with 1/4 times x, 1/4 times x. We'll use inverse operations. The inverse of multiplication is division. Therefore, we will divide both sides of the equal sign by +1/4. This will leave us with x equals -1/4 divided by +1/4 is -1. Our final solution is x equals -1. Here's our last example. Solve. m/5 minus 3 times the difference of 2 minus 1/5 m equals -2 plus 5 plus 1/5 m. We'll begin the problem by drawing the line down the equal sign to balance the equation. Now we'll use our acronym DCMAM, or Don't Call Me After Midnight, to guide us in our problem solving. Let's check for the distributive property. On the left side of the equal sign, there are parentheses. So we'll multiply -3 times 2, which is -6. Now we'll multiply -3 times -1/5 m, which is +3/5 m. Now we'll look on the right side of the equal sign to see, are there any parentheses? No parentheses, so we'll just bring everything else down. Now let's move on to the next letter, C, combine like terms. Let's check on the left side of the equal sign. Are there any like terms? Yes. m/5 and the +3/5 m are like terms. They both have the letter m. So we'll add m/5 plus 3/5 m. That's the same as saying 1/5 m plus 3/5 m, and that'll leave us with 4/5 m. And we can go ahead and bring down the -6 since that wasn't a like term. We could just bring it down. Now let's check for like terms on the right side of the equal sign. Remember, we're balancing this equation. Are there like terms? Absolutely. -2 plus 5, those constants are like. So we'll combine them by adding -2 plus 5. That'll leave us with +3. Everything that we haven't touched, that +1/5 m, we can just bring it down. Don't forget the equal sign as well. Now we'll move on to the next letter, M. Move these smaller variables. First off, are there variables? Are there letters on both sides of the equal sign? Yes. On the left side of the equal sign, we have 4/5 m. On the right side of the equal sign, we have positive 1/5 m. Which variable term has a smaller coefficient? You got it. 1/5 m is the smaller variable. Therefore, we will do the opposite of that whole term. The opposite of plus 1/5 m is to subtract 1/5 m from both sides of the equal sign. This will leave us with 4/5 m minus 1/5 m is 3/5 m. We'll bring down everything else. The minus 6 equals 3. Moving on to the next letter in the acronym A. Add or subtract the constant term. 3/5 m, that's our variable. It's not isolated because there is a constant on this same side of the equal sign. So that constant is minus 6. Now what we'll do is do the opposite, do the inverse of minus 6, which is to add 6 to both sides of the equal sign. This will leave us with 3/5 m equals 3 plus 6 equals 9. The last step is m. That last m stands for multiply or divide. We see that the letter m is on the left side of the equal sign, 3/5 m. 3/5 times m. The inverse or the opposite of multiplication is division. Yes, you guessed it. We're going to divide both sides of the equal sign by 3/5. Resulting in m equals 9 divided by 3/5 is positive 15. Our final solution is m equals 15. Now it's your turn. Solve. Negative 2/3 times the difference of 7 minus w equals negative 6. I know you got it. Let's go. All right, let's check it. Your final solution should have been w equals negative 2. Did you get it? Spectacular! Now let's check your work. Okay, ready for the next example? Solve. X over 3 plus 15 minus 8 equals 2 plus 4. I know you got this. Let's do it. All right, let's check our work. You should have been left with w equals negative 2. Did you get it? Amazing! Now let's check our work. Let's try the next problem. Solve. 21 minus 2 times the sum of f plus 3 equals 3f. Take your time. Let's go. All right, let's check our work. You should have been left with f equals 3. How did you do? Amazing! Now let's check your work. Here is our last example. Solve 4a plus 3 minus a equals -7 plus 2 plus 8. Take a deep breath. You've got it. Let's go. All right, let's check our work. You should have been left with a equals -4. How did you do? Amazing! Yes, let's check our work. All right, how did you do? Are you ready to begin the next skill? I am so honored that you participated and that you persevered. Be sure to tune in again and again and again to see what's happening with Miss Harris. Please know that you're loved, and with God, all things are possible. Toodles. Mwah.
What we do here is go back.